Imagine a time when machines were nothing more than cogs and gears, their only purpose to perform simple mechanical tasks. Now fast forward to today, where intelligent systems guide us in everything from navigation to creative inspiration. But where did this incredible journey begin? Who planted the seeds for what we now call artificial intelligence? To answer that, we have to travel back to the early 20th century and meet the brilliant mind of Alan Turing, the father of modern computing and the spark behind AI's existence. To truly appreciate Alan Turing's contributions, we first need to understand the world he was born into, a world untouched by digital technology. In the early 1900s, the concept of a thinking machine existed only in science fiction. Computers, as we think of them, did not exist. Instead, computation was a human task, often carried out by groups of people who manually solved equations and processed data. It was a time when the limits of technology were defined by mechanical engineering, not abstract logic or mathematics. Machines could perform repetitive tasks, but the idea of a device solving complex problems or mimicking human thought, that was beyond imagination, until Alan Turing changed everything. Alan Turing was born in 1912 in London, England. From a young age, he exhibited an incredible aptitude for mathematics and logic. Turing was not just brilliant, he was a visionary. He wasn't afraid to ask bold questions like, could a machine ever think? By the 1930s, Turing was studying mathematics at King's College, Cambridge, where he began to explore ideas that would later revolutionize the world. His brilliance wasn't just in solving mathematical problems, but in reimagining what mathematics could do. In 1936, at the age of 24, Turing published a paper titled On Computable Numbers with an Application to the Entscheidungsproblem. Now, I know, just hearing that title might make your head spin, but let's break it down. In this paper, Turing introduced the concept of what we now call the Turing machine. It wasn't an actual machine, but rather a theoretical model, an abstraction, that could perform any computation if given enough time and the right instructions. Think of the Turing machine as the ancestor of all modern computers. At its core, it's astonishingly simple. A tape, like an endless strip of paper that can store symbols, a read-write head that can manipulate those symbols, and a set of instructions dictating how the machine operates. Despite its simplicity, the Turing machine could solve any problem that could be described algorithmically. Turing's insight was profound. Computation isn't about the physical machine. It's about the logic behind it. This shifted the focus from building mechanical devices to creating mathematical models of problem solving. During this same period, the field of mathematics was wrestling with big fundamental questions about the limits of computation. One of these questions, posed by the German mathematician David Hilbert, was whether every mathematical problem could, in theory, be solved by a systematic procedure, a step-by-step algorithm. Turing's work answered this question with a groundbreaking conclusion. No, not every problem can be solved algorithmically. This realization didn't just advance mathematics, it also laid the foundation for computer science as a discipline. But Turing's ideas didn't stop there. He was just getting started. During World War II, Turing applied his brilliance in a way that would change the course of history. The Nazis had developed a cipher machine called Enigma, which they used to encode their military communications. Cracking this code was critical to the Allied war effort, but it seemed impossible until Turing arrived at Bletchley Park, Britain's code-breaking center. Turing and his team built an electromechanical machine called the bomb, which automated the process of deciphering Enigma's codes. The bomb wasn't AI as we think of it today, but it was a pivotal moment. For the first time, machines were used to perform tasks that required logical reasoning, albeit in a highly specialized way. The bomb and Turing's work at Bletchley Park didn't just shorten the war, it demonstrated the potential of machines to augment human intelligence. It was a glimpse into what the future could hold. After the war, Turing turned his attention back to the big questions. Could machines think? Could they learn? In 1950, he published another landmark paper titled Computing Machinery and Intelligence. This paper asked a question that continues to fuel debates today. Can machines think? Rather than getting lost in philosophical definitions of thinking, Turing proposed a practical test, the imitation game, now known as the Turing Test. Here's how it works. Imagine a human judge converses with two entities via text. One human, the other a machine. If the judge can't reliably tell which is which, the machine has demonstrated intelligent behavior. The Turing test wasn't just a challenge to engineers, it was a philosophical statement. Turing was saying, if a machine can convince us it's thinking, does it matter whether it actually thinks the way we do? This idea was revolutionary. It shifted the focus from trying to replicate human thought processes to evaluating the outcomes of those processes. In other words, it didn't matter how the machine got there, as long as it performed the task effectively. Sadly, Turing didn't live to see the full impact of his work. He died in 1954 under tragic circumstances, a victim of societal prejudice that overshadowed his genius. But his legacy endures. Every computer, every algorithm, every AI system we use today traces its roots back to Turing's ideas. He showed us that machines could do more than automate. They could compute, solve problems, and perhaps one day even think. But Turing's legacy isn't just technological, it's philosophical. He challenged us to redefine intelligence, not as something uniquely human, but as a capability that can emerge under the right conditions. So why does Alan Turing's story matter to us now, in the age of AI? Because understanding the origins of AI helps us understand its potential and its limits. Turing's work reminds us that intelligence is not confined to biology. It's a set of processes, a dance of logic and patterns that can exist in silicon as well as neurons. This realization opens the door to incredible possibilities, but it also challenges us to ask important questions. What responsibilities come with creating intelligence? How do we ensure AI aligns with our values? And perhaps most importantly, how do we prepare ourselves to coexist with increasingly intelligent systems? Turing once wrote, instead of trying to produce a program to simulate the adult mind, why not rather try to produce one which simulates the child's? This simple question captures the essence of AI. It's not about recreating ourselves, but about nurturing systems that can grow, learn, and surprise us. Today, we've explored the roots of AI, but this is just the beginning of the journey. Every innovation in AI, from neural networks to natural language processing, builds on the foundation Turing laid. His legacy reminds us to approach AI with curiosity, humility, and a sense of wonder. As we continue this exploration of AI's history and core concepts, let's carry Turing's spirit of inquiry with us, questioning not just what AI can do, but what it should do. After all, the future of AI isn't just about machines. It's about us. It's about how we choose to shape this technology and how, in turn, it shapes us.